Hi everybody and welcome. In today's video we're going to be talking about the follow-up to the law of sines. You guessed it, the law of cosines. So first things first, what is the law of cosines? It's a relationship that allows us to solve for unknown sides or angles if we have two options here. We can either have all three sides or two sides and an included angle. Included angle is just a fancy way of saying the angle that is between the two sides that we know. So for example, if we're looking at a triangle like this and we know side x and side y, the included angle is in between them. So none of the other angles in the triangle work. It specifically has to be directly in between the two ones that we in fact know. So the law of cosines here actually has three different options, and the options just depend on what you're given, but all three of these work. Just a different arrangement of A, B, and C. So first things first, we're still using our same ABC triangle. And within this triangle here, the relationships are as follows. So we have a squared equals b squared plus c squared minus 2bc times the cosine of a. And again, if we're looking at this, I know it seems like a lot, but it's a few quantities repeated. We can color code these to show like where all of these things are. So like little a, little b, little c, and then just using our big angle A here. So that's the first iteration that uses angle A. There's two other iterations. One iteration uses angle B, and one iteration uses angle C. So we also have b squared equals a squared plus c squared minus 2ac times the cosine of b. The way that I think about these going through it is whatever your first term is equal to is also going to be the angle. And if that is what's kind of on your edges, so if you have like b is the bookend, so little b at the left side and big B on the right side, in between them is A and C. So like the two side lengths, we're adding A and C together, and we're multiplying A and C as well. So if that kind of helps you, that's how I honestly remember this. So again, the big angle that you're solving for is the side on the outside, and then the other two sides are the ones that we use on the inside here. So same thing, go through and highlight here for consistency's sake. So there's our little c. Our little b is here now. Our little a is both here and here. And then now we're introducing our new angle, angle b. The last one is a very similar format, a very similar setup. C squared is on the outside, which means that B and A are in the inside. And then it's the cosine of C. So again, here is little c, here is little a, here is little b. And our new angle, so we have to pick a new color here. I'm gonna try that light one, see if that works. That is our big C. So that's how we set these up, and kind of once we're in the situation, it's more or less the same thing as law of sines in terms of we're just plugging things in. So we're going to go over two examples of plugging things in, but that's kind of the idea. So if you have these three formulas as a reference, we're just kind of deciding which one do we need to use first, and then after we decide which one we need to use, we're plugging things in and solving for the only thing that we don't know. So let's start off with an example question. And for this one, we're given the following triangle. told that this side is 5, this side is 7, and we have the included angle, which is 36. So good practice. Let's label what each of these things are. And now we need to determine what one of these formulas do we use. So in the case where we have two sides and one included angle, the included angle that we use, the included angle we have is the one that we have to use. So in this case, we have to use number 2 because that's the only one that has the cosine of b. That's the only one that uses capital B. So let's write that one down to start. And let's identify what we know so far. So we don't know if this is a right triangle, so we can't solve for our last missing side because, again, in this case, it's not the Pythagorean theorem because we don't know if it's a right triangle. So we're just going to take this one step at a time and basically plug in everything that we do know first. So we know that little a is 7. We know that little c is 5. So again, little a is 7 and little c is 5. And we know that the cosine of b, in this case, is cosine 36. So if we go through here, basically at this point we're just evaluating. So we'd put these things together. We would have 49 plus 25, and then minus 2 times 7 times 5 times the cosine of 36. So let's go ahead and punch all that in. All right, so we have cosine 36 times 2 times 7 times 5. And that value is going to get us like 56.63. So we'll take 49 plus 25 minus 56.63. And that'll get us a b squared value of approximately 17.4. And then to solve for b here, take the square root, we'll get b equals approximately 4.2. So again, very, very similar to law of sines in that when we get to this point, we're really just plugging things in. So we're really just taking the little a, the little c, the angle that we know, and we're just plugging those things in. When we do that, we're going to be able to solve for other things that we don't know. So in this case, the new thing that we solve for is that this little b equals 4.2. So now your question might be, okay, what's next? So how do we solve for these other two angles? Well, you actually have some choices here. So because we have all of the sides, if you'd like to, you can use law of cosines again. So you could this time plug in everything except for the big angle A or the big angle C. You also have enough information to use a law of sines. If you think about it here, we have both big B and little b, which means that we can use the other sides across from A and C to solve for both of those as well. So in this case, that would actually be my recommendation. I think the law of sines is a little bit less complicated. There's a few less things to do. So we could take the fact that we know both of our b terms and use that to set up for something we don't know. So in this case, maybe we could use the sine of c over c. So we know sine of 36 over 4.2 equals the sine of c over 5. And then at this point, we can go through and cross multiply. So I'll have 5 times the sine of 36 equals 4.2 times the sine of c. We want to get the sine of c by itself, so we can divide both sides by 4.2. So we'll have the sine of c equals 5 sine 36 over 4.2. And then the last step here to get c by itself, we're going to use the inverse sine of 5 times the sine of 36 over 4.2. And that's going to give us our c value. So that's, again, review of law of sines from last week. Punch all of that into our calculator with our inverse sine. When we do that, we should get an answer of c equals 44 degrees. So again, review from last week, review from 9.1, but again, applying that skill to solving for this triangle. So c in this case, again, 44 degrees. So the last step is, well, how do we solve for our final angle A? Well, we have two angles of a triangle, so some more review here from geometry. All the sides of our triangle add up to 180 degrees. So in this case, we know 44, we know 36, and the last one we're left with is angle A. So we can put both of these together to get 80 plus A equals 180. We can go through and subtract 80 from both sides, and we'll be left with A equals 100 degrees. So we have fully solved this triangle now. And again, we had to start off with the law of cosines. We didn't have any other choices because we just didn't have enough information to do anything else. But now we can kind of combine that with the law of sines, with our knowledge of triangles, to fill out everything else in a triangle that we're looking for. We're going to do one more example here, in another case where we have to use the law of cosines, except this time we're going to talk about what happens when we only have basically the sides given to us. So we had a side angle side example here. So now for example number 2, a little bit of extra practice. We'll talk about when we have all three sides given to us, but not in a right triangle. So in this case, again, we can't use the Pythagorean theorem because we don't know if it is or isn't a right triangle. So always start off good practice by labeling these sides. And then let's start off and seeing what we want to solve for. So we're going to have to solve for everything, so we might as well start off with A. So if we're going to start off with A, what that means is we're going to need to use the law of cosines that uses our A value first. This is the only one that has big A for our angle, so because of that, that's what we're going to put up there to start. So some things that we know that little a equals 16, we know that little b equals 9, we know that little c equals 10. So again, we're still plugging in all of these things. But what we don't know is big A. We don't know that angle. And if you look at this, that's the only variable we have. Everything else is just numbers. So that's good for us here because that means that we're ready to go through and solve. So start off, just evaluate order of operations kind of as we're going. So 256, 81, 100, and then minus 2 times 9 times 10, 180 cosine of A. Put these two terms together, get 181. Let's bring this 181 over. $75. And then now we want to keep solving so that we just have the cosine of A by itself. So divide by negative 180. And we're left with that equals the cosine of A. So now that we're at this step, we can go ahead and take that inverse sine of A, inverse cosine of A, and kind of switch our terms around here. Don't forget that negative when you do. That's going to help us go through kind of one step at a time here to solve for everything that we're looking for. So I got to punch this into my other calculator here, but when we go through and do this, we should get that final answer of A equals 115. So again, always good to just take a pause here, check your work, make sure that we're not missing anything, plug in all those values, and again, one step at a time. This definitely takes quite a bit of patience, quite a bit of work to make sure that you're not making any mistakes as you go through. But if you're careful, you'll find that the outcome that you're looking for here is, again, something that's going to work out and it's going to make quite a bit of sense for you. So getting that final value here, A, 115 degrees, is going to help us to move forward with our next step. So thinking about this, a good time right now to take a kind of a big step back and take a look. through what we've been doing and what the best next step is to save you some time. So in this case, if we're looking at it, we need to find some angles. We have some information, and it looks like the law of cosines would be something we can use. It also looks like we could use the law of sines as well. So this is how we solve for angle A. We can next move on and solve for angle B using the information that we already have. So here we'll have sine of 115 over 16 equals the sine of B over 9. Again, opportunity to cross multiply. 16 sine of B equals 9 times the sine of 115. And then here, divide by 16, divide by 16. So we'll get the sine of B equals 9 times the sine of 115 over 16. Use our inverse sine function again to get B equals 9 times the sine of 115 over 16. And then finally take that, punch it all into your calculator, and get an answer of B equals 31. So again, quite a bit of calculator math here, applying the two skills we've had. Again, this is 9.1 video review skill using the law of sines. So we'll get our B value of 31. And then the last thing that we're going to do, and when he's making a guest appearance, if you can hear him in the background here, always some good energy for us, is just use geometry knowledge. So we have 180 degrees. We've already solved for one angle as 115, another angle is 31. So our last angle we haven't solved for yet is C. So put these things together. 146 plus C is 180. Subtract 146 from both sides. We'll get an answer of C equals 34. Now it's going to be our final angle in our triangle. We fully solved for a triangle where we just have the sides. Now we have enough information to give all the angles as well. So I'd say for today, focus on getting comfortable choosing the law of cosines formula that applies, plugging these values in, and again, working through some of that calculator math to get